So we want to talk about the applications of trig graphs. We've talked about them in terms of how to find the graph from an equation and how to find the equation from a graph, but why do we want to know that? Okay, in other words, why are they useful to us? And basically, they're useful anytime you're looking at a situation that is periodic in nature. If you've taken physics, you know something about simple harmonic motions. You know about pendulums and you know about masses on springs. Those are the two things you talk about in physics in terms of simple harmonic motion. And those could actually be examples of periodic motion because you found the period in both cases. All right, it's the square root of L over G, I think, in one case, and M over K or something like that. I forget the exact formulas right off the top of my head, but you probably remember T equals and T equals for those. So we're talking about periodic stuff like that. Okay, a couple other situations, anything that is cyclical, like the tides. We live in St. John, New Brunswick, which has some of the highest tides in the world. So you know, or you're well aware of the change in the tides. And it goes from high tide to low tide, back to high tide to low tide, back to high tide, and it does that in a cyclical way. So we can actually model the height of the water using a sine function because it's going to come up and down and up and down and up and down. Anything that goes around as well, any sort of wheel. So water wheels, Ferris wheels, you won't ever look at a Ferris wheel the same after you're done doing these trig graph applications. Okay, so what we're basically going to try to do is we're going to try to take a situation and draw a graph. And once we recognize that that graph is sinusoidal, we're then going to try to find the equation. Okay, I'm going to show you how to do that. But what we're going to say while we do that is in order to do that, our x-axis are not going to be in radians or degrees. It's going to be in time generally. All right. So if you think about the tides, they cycle every 12 hours. If you think about a Ferris wheel going around, it's going to go around in a certain amount of time. So the x-axis on all of these is actually going to be time. And that means that we have to then decide what our b value is going to be reported in. Is it going to be reported in radians or degrees? All right, our b value is going to change. So we're going to work on radians for all word problems, all right? Just so that we always find the b value using a ratio of pi. So we look at a question and say, how do we do this? So it says, if we look at a Ferris wheel, that the Ferris wheel has a diameter of 10 meters and it rotates once every 12 seconds. The bottom of the wheel is 0.5 meters off the ground. So here's what we're going to do. We're going to draw a Ferris wheel. Here's my Ferris wheel. I'm going to add a sort of bottom to this. All right, so let's imagine that it looks kind of like this. But this distance, it tells me, the height of there, right there, is 0.5 meters. And then it tells me the diameter is 10 meters. So that means this distance is 5 meters. And then this distance is 5 meters. Okay? So it says it rotates once every 12 seconds. That's giving me the period. So what I want to do is I want to go up. I want to look at what happens here. Okay, what happens here, back to the middle, and then at the bottom again. So right here, how long does it take to get there, first of all? So I'm going to look at time, and then I'm going to look at height. So at 0 seconds, we're at 0.5. We're assuming we get on at the bottom of the Ferris wheel. Okay, and then if it rotates every 12 seconds, a quarter turn is going to be 3 seconds. So I'm going to go 3, 6, 9, and then back to 12. Okay. At 3 seconds, I'm right here. That is 5.5 meters off the ground. I think you can see that. All right, actually, I'll put the height in meters here and the time in seconds here. And then if you go to 6 seconds, you're at the top, and the top is going to be 10.5. So we have 0.5, 5.5, 10.5. 9 seconds is going to put us back down to here. So that's at 5.5 again. And then finally at 12, we're all the way back around. So we're at 0.5 again. And all we're going to do is then graph those points. Okay, so I'm going to go up by 3 on my x-axis, 3, 6, 9, 12. And I'm going to say this now, and I hope you hear me because it's going to be true all the time. You always want to go on your x-axis by a quarter of the period. Okay, you always want to go up by a quarter of the period. And then here, I've got to go up to, I'm going to go 2, 4, 6, 8, 10. Okay, so if this is 10, here's 10.5. 2, 4, 6, 5.5 is sort of here-ish. I'm going to label that as 5.5, and 0.5 is right here. Okay, so I start at 0.5, then at 3 I'm at 5.5, so we've labeled that here. Then I'm at 10.5 at 6, then I'm back to 5.5 at 9, and then finally I'm back down to 0.5 at 12. So my graph looks like this, okay? Now, once you're there, you have a graph, you want an equation, so all you have to do is identify, here's my middle, right, 5.5. So that's my k value, so k is 5.5. I can see my amplitude. My amplitude is the difference right here. This is my amplitude, which is my a value, and it's going to be 5. Okay. I can figure out what my period is. Sorry, my b value is from my period. So my b value is just for sine and cosine, which is what this graph is, and which they all are, is going to be 2 pi divided by 12. That's my period. So that's pi over 6. Okay. And the last thing to do is to find the h value. Now, what's interesting about this is that we actually can find the h value using sine or cosine. So if we imagine sine, we're looking at sine always starts in the middle. So there's my middle and goes up. Okay, so if that's the case, my h value for sine is going to be 3 because it's shifted. It usually starts in the middle and goes up. Now it's shifted and it's at 3, it goes up. All right, it's in the middle and goes up. For cosine, you have two options. Okay, cosine normally starts at a peak, so you could use h is 6, or you can use a negative a value and an h value of 0 because that starts at the bottom at a crest. All right, so your options for an equation are this: y is equal to a, we said was 5, and then if we use sine, it's going to be sine of pi over 6 onto x minus 3 plus 5.5. That's your option for sine. For cosine, we're going to say you have exactly the same thing. Okay, the only difference is the h value. So you can either do this, okay, or you could do minus 5 cosine of pi over 6 x plus 5.5, where you start, instead of starting at the peak, you start at the crest or the trough. Sorry, not the crest. So those are your options for the equation. Now you get to pick, unless it says find sine or cosine, you get to pick. So you can pick whichever one you want. Okay, you can either use sine or cosine, and you can also either use negative a, or you can always use a positive a value. That's up to you. Okay, so let's do another example. We've got a Ferris wheel with a radius of 10 meters that rotates once every 60 seconds. Okay, so that tells me my period is 60 seconds. The diameter is 10. That means the radius is 5. Sorry, the radius is 10. So misread that. So that's 10, and that's 10. And it says passengers get on board 2 meters above the ground. All right. So what I like to do is I just like to say my high point is going to be then 22 meters. My middle is going to be 12 meters. And my low point, which is the bottom of my graph, is going to be 2 meters. All right, we can see that 2 meters, and this is at 12, and then the top is at 22. And since the period's 60, I'm going to go up by a quarter of that. All right, so a quarter of 60 is 15. So I'm going to go 15, 30, 45, 60. All right, and my x-axis, I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, so this is 22. This is 2, and then 2, 4, 6, 8, 10, 12. There's 12. And I'm going to draw my graph. We get on at the bottom, so we get on at 2, and then every quarter of the period, we're going to be in the middle, then we're going to be at the top, okay? Then we're going to be back to the middle, and then finally we're going to be back at the bottom. All right, so the graph looks very similar to the one we just drew because it's a very similar question to the one we just did. So there's my equation. Sorry, my graph. Now I got to find the equation. So I know my amplitude. If you look the middle, you can clearly see I already know the middle, right? Because I actually mentioned it here. So the middle is the k value. So k is 12. The difference between the top and the middle, so 22 minus 12, is going to give me my amplitude. And for your purposes, just so you know, it's always the amplitude is always the radius of any wheel that you have. So if whatever the wheel is, the radius is the amplitude. Okay, our b value comes from our period. So we're going to go 2 pi divided by our period, and our period in this case is 60. So we're going to get a b value of pi over 30. And then again, we get to decide for h, we have to decide, are we going to use sine or cosine? If we use sine, we're looking at where is it in the middle, there's my middle, and goes up. So that's at 15 seconds. So sine, the h value is 15. And then for cosine, just like last time, we can either use a negative a and h to be 0, or a positive a and h to be the first peak, and the first peak is at 30. So that means your equation is going to be for sine, it's going to be, and for cosine too, the only difference is the h value, right? So for sine and cosine, the a value is 10. And then if we put sine in here, our b value is pi over 30. And then we have x minus h. H, for our purposes, is 15. And then plus k, which is 12. All right, for cosine, it's the exact same thing, except it's going to be, I don't need that E on there. Sorry, I don't need to write in sine like that. It's just SIN. So we have cosine of pi over 30, x minus, and then either 30, okay, plus 12, or y equals minus 10 cosine of pi over 30 x plus 12. Okay, so that's our equation. So the first part of this question said, write an equation. We just did. Now it says, where is she going to be when the wheel's in motion for 2.3 minutes? So 2.3 minutes, what we have to do, part B, is we're just basically given an x value. We're told x is 2.3 minutes. Now our equation is in seconds. So we got to multiply 60 seconds in 1 minute. All right, we have to take 2.3 times 60, which is 138. And then what you're going to do is you're going to plug that 138 into one of these equations. It doesn't matter which one. And in fact, you're never going to be asked to produce 3 equations. I'm just showing you those because that's what they are. But you're never going to be asked to do a whole bunch of them. You only have to do one. So let's just use the sine graph just because. So that means y is going to be 10 sine of pi over 30 times 138 minus 15, and then plus 12. Okay, and then we just follow this through. So we go 10 sine of pi over 30, 138 minus 15 is 123, plus 12. Okay, and then I take my calculator. I'm going to take 123 and multiply it by pi, and then I'm going to divide that by 30, and then I'm just going to check. I'm going to put myself in radians, and I'm going to hit the sine of that. Okay, then I'm going to times that by 10. I'm going to add 12, and it looks like I'm at about 15.1 meters. Okay, so hopefully that makes sense. All right, in terms of finding the place where you're at, and it makes sense to us if you look at your graph, because 2.3 minutes is 2 periods and then 18 more seconds. So let's imagine I'm at 18 seconds, forgetting about the first 2 periods, but it makes sense that it's somewhere in 15 because that's 14. So it makes sense. It's a reasonable answer. The only thing to be aware of is you got to make sure that your calculator is in radians. All right. So what I want to do now is just look at, we're going to skip this because this is the same kind of question. I'm going to leave it there for you to try, but we're not going to go through it. It's exactly the same idea. It's a Ferris wheel. It has a diameter of 10. It has a center at 6 above the ground. It rotates every 30 seconds. The only difference actually is that it tells you that it has a center at 6. So if the diameter is 10, just to sort of point this out, if I draw my Ferris wheel very roughly, if the diameter is 10, then that's 5 and this is 5. If the center is at 6, that means the height above the ground, if this is the ground, is 1. All right, so it's 1 meter, and then 5 and 5. And it gives you the period. So you can do this the same way that we would have before. The only difference is you'll notice it says it wants a time during a 1 minute ride. So that means you have to do 2 full periods. You have to draw it twice. Okay. But I want to look at a tide question because that's the other type of question that you're going to have to do. So the difference between high tide and low tide, it tells me in this example, is 20 meters. And it says to draw a graph of the height of the water above mean sea level and then find an equation. Now, it doesn't tell us where to start. Sometimes it does, but in this question it doesn't. So that means we can start wherever we want. So I'm going to start in the middle. And the middle is mean sea level. It's the average, okay? So if the difference is 20, that means the high tide is 10 above the average and low tide is 10 below the average, okay? And then it says I want to draw it for a 36-hour period. That is not telling you that it's a 36-hour time frame that go from high tide to low tide. It's not telling you the period. The period is always 12 hours for tides, every time. So when it says I want you to draw it for a 36-hour period, what it's really saying is I want you to do it for 3 cycles. So we're going to do that. So we're going to go up by a quarter of the period, right, every time. So 3, 6, 9, 12, then 3, 6, 9, 12 more, and then 3, 6, 9, and 12 more. Okay, so we're going to go up to 36. So we're going to start in the middle, then we're going to go to the highest point, then we're going to go to the middle. This is what sine does, right? Then it goes to the lowest point, and then back to the middle. Then we're just going to repeat the exact same process. So up to the top, back to the middle, down to the bottom, back to the middle, then up to the top, middle, bottom, and back to the middle. So my graph looks like this, right? Just kind of go and connect the dots, and I'm doing my best I can with the tablet that I'm using. All right, I might miss a point or two, but I'm sure you'll be gracious enough to forgive me. So if you look at these, it wants an equation. So the first thing I notice is that the period is 12 hours, so that means my B value is 2 pi divided by 12. So my period is pi over 6. I notice that my amplitude, my A value is 10 because it goes up 10 and then goes down 10. And I notice that the middle of my graph is actually 0, so that means K is 0. And I also notice that this starts in the middle, so I'm just going to use a sine graph, and I'm going to say H is then 0 because this starts in the middle and goes up. So the equation then that I'm going to write out is y is equal to, and then 10 sine B is pi over 6 x, and then plus h, minus h, and then plus k, but they're both 0. So this is my equation. Okay, and that's how we would do that. Now the difference here, if you jump back to the Ferris wheels, we were doing height above the ground, right? So you notice it's the lowest point is still above the ground. This graph asks you about mean sea level. So it's the reference point that has changed. And sometimes it happens with Ferris wheels too. You'll be asked to draw it from the center of rotation. So you really just have to be careful what your midpoint is, okay? Or what the middle is. So if you look at this graph, it's the exact same thing. So again, I'm not going to go through this with you. I want you to try this one on your own, okay? But it tells you the difference between high tide and low tide is 15 meters. So that means you're going 7.5, half of 15 above, and 7.5 below, because it's telling you that mean sea level is where you want to start. Okay, so you want to start here, and it wants again 12 hours, so 3, 6, 9, 12, and then 3, 6, 9, 24. It asks you to do it for 24 instead. So all you're doing, starting in the middle, I guess I am going through this at this point, but going to the highest point, middle, lowest point, back to the middle, highest point, middle, low point, and then back to the middle. You draw your graph, and if you start in the middle, it's really easy, okay? Because K is 0 because your middle is 0, and H is 0 because you're starting in the middle. If it says to start at low tide, okay, it doesn't say here what we have to start at, but if it starts at low tide or starts at high tide, your H value is going to change. But since it doesn't say, I'm always going to start in the middle. the A value is 7.5, and the B value is the same as the last example. It's 2 pi divided by 12, or pi over 6. So your equation just becomes 7.5 sine of pi over 6 times x. All right, and you can use h and t if you want to, height and time, but that's the idea. Okay. Here's another example. This one, though, it doesn't tell you. It just says high tide's 22 and low tide is 10. So it doesn't tell you to start in mean sea level mode. It just gives you the actual physical heights. So if you start at 10, let's go 5, 10, there's 10, 15, 20, 25, let's say, all right, is up there. Then you have to find the middle. And the middle is going to be at 16. So, okay, because that's the middle point. And then 22, let's say that's 22. Okay, so 22 is my high point, 10 is my low point. So 6 in between in each direction is going to be 16. That's my middle. Okay, my middle is 16. And then period's still 12. So I'm still going up by 3. All right. And what I'm doing is I'm going to start at 0. It doesn't tell me where to start. So I'm going to start in the middle because that makes my h value 0. That's why I'm doing that. And then I'm going to go to the highest point, which is 22, then back to the middle. Okay, then down to the lowest point, which is 10, and then back to the middle. Now it says to do it for 48 hours. So you would continue that, and I'm not going to, just for sake of time, because this video is getting a little long. But you would just continue this same cycle, top, middle, bottom, middle, top, middle, bottom, middle, for 4 sets. So if we just look at this first set, just so you can get an equation, we know that h is 0 because we're starting in the middle and going up. We know that k, the middle, is now 16. We know the amplitude then is 6, okay, because it's the difference between the middle and the top or the middle and the bottom. So the amplitude is 6. And the b value, because it's pi, is always going to be pi over 6 hours. It takes 12 hours to complete a full cycle. So my equation becomes y is equal to 6 sine, and then my b value is pi over 6 x, and then plus 16. That's my equation. All right, so that's how you do trig applications. And if you're wondering, there is no trig application for tangent. It's all sine and cosine. So hopefully that makes you happy. All right, so we're going to leave it at that. You can try a bunch of the applications yourself and reach out to your teacher for help if you need it.